Hello there, and welcome to the Sleepy Scholar. Tonight's journey takes us out into the vastness of the ethereal world of the Northern Lights, or the Aurora Borealis. We are leaving behind the clamour of the day and stepping into a celestial theatre, where the cosmos itself paints the heavens with colours born of ancient solar breath, a silent, swirling majesty, witnessed by those who dwell beneath the deepest, quietest skies. The air grows cold and still as we lift our gaze, trading the small worries of the ground for the vast, rhythmic pulse of the Earth's magnetic heart, a place where light dances with the very fabric of space and time. This story is not one of frantic discovery, but of quiet, profound observation, allowing the sheer scale and subtle science of the aurora to wash over the busy mind, turning stress into a tranquil wonder. The lights do not rush, they simply are, a timeless phenomenon that invites us to slow our own internal rhythm until it aligns with the gentle cosmic currents above. If you enjoy these quiet explorations, consider subscribing so you can easily return here whenever you need to rest. For now, get comfortable. Let your eyes grow heavy. Let's begin. The Northern Lights are scientifically known as the Aurora Borealis, a name that whispers of ancient deities and the dawn of the North. This beautiful dual naming carries within it the weight of history, where Aurora is the Roman goddess of the dawn, perpetually chasing the sun across the heavens, and Borealis is the simple grounding Greek word for the northern wind, linking the celestial spectacle to the familiar cold breath of the northern latitudes. The phenomenon itself is nothing less than the solar wind, a steady, energetic stream of charged particles that flows continuously from the sun's expansive outer atmosphere, encountering the Earth's own invisible yet mighty magnetic field, which acts as a protective shield for the planet. The sun's breath travels an immense distance, over 90 million miles, or about 150 million kilometers, before it is gently guided toward the poles, an act of planetary physics that transforms invisible forces into one of the most visible and majestic displays in our atmosphere. This constant interaction reminds us that our small, sheltered world is perpetually enveloped in a vast, silent conversation with our distant, fiery star, a conversation written in light upon the canvas of the polar sky. The colors of the aurora are determined by the specific gases that are energized by incoming solar particles. The most common and recognizable color, a haunting, luminous green, is the signature of oxygen atoms residing at lower altitudes, typically around 60 miles, or about 100 kilometers above the Earth's surface. When these charged particles from the sun gently collide with an oxygen atom, they momentarily excite the atom's electrons, which then relax back to their original state and release the excess energy as a photon of light, creating that familiar emerald glow that seems to ripple like silk. Higher up, at extreme altitudes, a rarer, deeper red color can also be produced by oxygen, showing us the layers of our own atmosphere painted in light, a quiet testament to the stratified nature of our terrestrial envelope. Nitrogen molecules are responsible for the beautiful, subtle blue and purplish red colors that often appear at the very edges or lower borders of the aurora, while the green of oxygen dominates the sky with its sheer brilliance. The nitrogen elements offer a more muted, ethereal contribution, adding depth and complexity to the overall display. The blue hues come from the ionization of nitrogen molecules, while the reddish-purple tones result from the excitation of nitrogen gas, and these tend to be less frequent and require greater energy in the solar wind To manifest, the presence of these richer colors depends directly on the intensity of the solar activity that is striking our planet's magnetic field. And so the lights can tell a subtle story of the sun's current mood, a whisper of its power translated into a gentle, shifting spectrum far above our heads. The solar wind travels across the interplanetary void at incredible speeds, often reaching over 1 million miles per hour, or about 1.6 million kilometers per hour. This velocity is a crucial part of the aurora's creation story, as the charged particles must carry immense kinetic energy to penetrate the outermost layers of the Earth's atmosphere and ignite the gases there. This sheer scale of speed, a silent, ceaseless flow of energy from the sun, is an awe-inspiring thought, demonstrating the profound engine of our solar system, which generates and propels matter across distances that dwarf our human conception of space. When this supersonic stream encounters the planet's magnetosphere, it is the initial moment of impact that sets the entire dramatic process into motion, like a vast cosmic percussion that resonates in the deep blue of the polar night. The Earth's magnetic field acts as a vast, invisible funnel, gracefully guiding the charged particles toward the magnetic poles. This powerful field, generated by the slow churning of molten iron in the planet's core, creates the auroral oval, a continuous ring of light that encircles the polar regions of both the north and south hemispheres. The magnetic field lines are concentrated at the poles, serving as the perfect smooth path for the particles to descend, a phenomenon of physics that beautifully translates into the geographic placement of the aurora. The light is visible in a broad band surrounding the pole, extending into latitudes like Alaska, Canada, Scandinavia, and Siberia, showing us the planet's own natural defense mechanism, transformed into a source of immense beauty for those who wait patiently beneath its curve. The most spectacular auroral displays are often triggered by coronal mass ejections, which are massive bursts of plasma and magnetic field that erupt from the sun's corona. These energetic events are like a powerful, deliberate sigh from the star, flinging billions of tons of solar material out into space at staggering speeds, far faster and more densely than the normal, steady solar wind. When one of these ejections happens to be aimed directly at Earth, the resulting magnetic storm can compress the Earth's magnetosphere with powerful force, dramatically increasing the number of charged particles that cascade down into the atmosphere. This intense influx is what produces the most vivid, rapid, and widespread auroral shows, turning the sky into a dynamic, shifting cathedral of light that can sometimes be seen far south of its typical polar home. The concept of the aurora has woven itself into the fabric of human myth and folklore across many northern cultures. To the Sami people of Scandinavia, the lights were often seen as the spirits of the dead, or sometimes as a tangible, living presence to be respected and feared, known as the revontuli, or foxfires, a spectral fox running across the snow and sparking the lights with its tail. To the ancient Norse, the lights were often viewed as the shining armor and reflections of the Valkyries, warrior maidens riding to battle, creating a majestic and powerful connection between the phenomena and their deep cosmological beliefs. These stories transform the cold, scientific reality into a narrative tapestry, showing us how the human heart seeks to personify the most sublime and inexplicable spectacles of nature, imbuing the silent light with both wonder and the enduring wisdom of ancestral memory. The aurora typically occurs at altitudes ranging from 60 miles to over 400 miles, or from about 100 kilometers up to more than 650 kilometers above the Earth. This places the light show squarely in the thermosphere and exosphere, regions of the atmosphere where the air is incredibly thin and the molecules are sparsely distributed, requiring immense distance for the solar particles to finally dissipate their energy completely. The lowest, sharpest edges of the auroral curtain are usually found around the 60-mile mark, which is about 10 times higher than a typical commercial jet flies, allowing us to perceive the vast, quiet distance between our terrestrial home and the ethereal dance floor of the solar wind. The sheer height of the display means that the light can be seen from hundreds of miles away on a clear, dark night. A towering, silent structure composed entirely of photons and magnetic grace. The sound of the aurora, a phenomenon known as auroral sound, is a subject of fascinating, ongoing scientific debate and local legend. While the lights themselves are physically created by particles colliding in the near vacuum of the upper atmosphere, making a direct sound wave impossible to hear on the ground, many people in high latitude regions report hearing distinct soft crackling, sizzling, or clapping sounds concurrent with the most vigorous and rapid displays. Scientists hypothesize that these rare reported sounds might be real, not just folklore, and could be generated much closer to the ground, possibly by the rapid heating and cooling of the atmosphere, or by the induced magnetic field, creating an electrostatic discharge that is audible to the observer. This sonic mystery adds a subtle, beautiful layer of complexity to the phenomenon, suggesting that the light show may carry a soft, barely perceptible whisper that only the quietest and most patient listeners are granted permission to hear. The auroral oval is a dynamic structure, constantly shifting its position and size in direct response to the strength of the solar wind and the magnetic conditions of space. During periods of low solar activity, the oval tends to contract and remain tightly centered around the magnetic pole, making the aurora a relatively predictable event for those living in the extreme north. However, when a powerful coronal mass ejection strikes the Earth, the oval expands dramatically, sometimes stretching its influence to lower latitudes, allowing people in places like the northern continental United States or Central Europe to witness the spectacular, fleeting colors in the southern sky. This slow, predictable breathing of the oval, a massive magnetic pattern over 2,000 miles, or about 3,200 kilometers in diameter, reminds us that the Earth is not a static object, but a living, magnetically charged entity, perpetually responding to the subtle and powerful forces of the Sun. The solar cycle, which is a roughly 11-year period of waxing and waning solar activity, directly impacts the frequency and intensity of the northern lights. During the solar maximum, the period when the Sun is most active with the greatest number of sunspots and ejections, the auroras are far more frequent, powerful, and visible at lower latitudes. Conversely, during the solar minimum, the quietest time for the Sun, the displays become rarer and weaker, often retreating back to the highest polar regions, visible only to those who venture deep into the icy stillness of the far north. This predictable, measured rhythm of the Sun, an ancient stellar clock that dictates the intensity of the light, allows observers to anticipate the seasons of greatest celestial wonder, connecting the deep, quiet rhythm of our star to the luminous dance above our heads. The faint red aurora, which is the rarest of the colors, is produced by high-altitude oxygen atoms at heights sometimes exceeding 200 miles, or about 320 kilometers. The production of this color requires a longer wait for the energized oxygen atoms to release their stored energy. A slow, gentle transition in the thin, nearly airless region, where space begins to truly assert its presence. Because of the lower density of gas at these extreme heights, the collisions that would quickly quench the excitement in lower layers are less frequent, allowing the red light to emerge from the silent void as a majestic, deep crimson arc. This slow blooming color often appears at the very top edge of the auroral curtain, like a soft, high canopy of light, a gentle cosmic blush visible only when the solar wind is at its most powerful and penetrating. The charged particles that create the aurora are primarily electrons, but they also include a smaller population of protons. While the electrons are the main workforce, generating the majority of the visible light as they spiral down the magnetic field lines, the protons also contribute to the phenomenon, though their light is much fainter and more difficult to observe. Often appearing as subtle, diffuse hydrogen emissions, the process of the proton aurora is slightly different, involving the capture of an electron by the proton, which then causes the atom to emit light as it de-excites, creating a broad, gentle glow known as the proton aurora, or sometimes the hydrogen arc. This subtle, less seen component of the display reminds us that the visible light is only one part of a much larger, more complex magnetic and particle interaction that continuously bathes our planet. The light of the aurora is actually relatively dim compared to sunlight or even moonlight, though the darkness of the polar night makes it appear brilliant. It is a soft, gentle luminance that the human eye perceives most vividly in the deep blackness, which is why the most spectacular auroras are seen far from the light pollution of human cities. The energy of the light is released over a wide area, creating a diffuse glow rather than a sharp, intense point, inviting the viewer to adapt their vision and quiet their expectations to fully appreciate the spectacle. This soft, quiet illumination, which often carries the spectral intensity of a faint cloud, requires patience and a gentle gaze, asking us to fully commit to the darkness before the light will truly reveal its inner grace and majesty. The shape of the aurora, ranging from diffuse patches to majestic, rapidly moving curtains, is controlled by the complex geometry of the magnetic field lines and the distribution of the incoming particles. The iconic curtain shape is created when a sheet of charged particles is channeled down a narrow, vertical sliver of the magnetic field, creating a tall, folded structure that can stretch for hundreds of miles. These curtains appear to ripple and fold as the magnetic field is gently perturbed and swayed by the solar wind, giving the illusion of a massive, shimmering piece of silk being moved by an invisible celestial breeze. This perpetual, hypnotic movement is a direct visual translation of the magnetic field's subtle, powerful dynamics, allowing us to see the very texture of the invisible forces that cradle our planet. The strongest auroras can induce currents in the Earth's surface, a phenomenon known as geomagnetically induced currents, or GICS. These powerful disturbances in the Earth's magnetic field can have a tangible impact on human technology, particularly long, conductive systems, such as power grids and pipelines, by generating excess current that can overload transformers. While this is a serious engineering concern, it also serves as a majestic physical testament to the immense power of the solar wind, showing us that the silent, ethereal lights in the sky are not merely an aesthetic display, but a true force of nature capable of generating global-scale electrical effects. The magnetic interaction reminds us that our technological world is intricately and delicately linked to the grand sweeping energy flows of the solar system, demanding both respect and deep understanding. The Aurora Borealis has a symmetric counterpart in the southern hemisphere, known as the Aurora Australis, or the Southern Lights. These two polar light shows are intrinsically linked, occurring simultaneously in mirrored patterns because the Earth's magnetic field is a single, continuous structure with two opposing poles. When a geomagnetic storm impacts the planet, the particles are funneled to both the north and south, ensuring that the light show is a global dual hemisphere event, a perfect magnetic symmetry that silently binds the icy stillness of the Arctic to the remote majesty of the Antarctic. Though the southern lights are less often witnessed by humans due to the sparser population and landmass near the South Pole, their existence affirms the fundamental balanced nature of the planet's magnetic response to the continuous solar breath. The phenomenon, known as substorms, is the process by which the stored magnetic energy in the Earth's magnetotail, the magnetic field stretched out behind the planet, is explosively released, dramatically intensifying the auroral display. During a substorm, magnetic field lines that have been stretched and held under tension for hours suddenly reconnect and snap back towards the Earth, accelerating massive numbers of charged particles down into the atmosphere in a brief, majestic cascade. This event causes a rapid brightening and increased movement in the auroral oval, turning a gentle glow into a truly dynamic, active show that can last for hours. The substorm is a beautiful, sudden magnetic resolution, a profound moment of energy redistribution that turns the quiet polar sky into a magnificent, energetic theatre. The color green, dominant in the aurora, is produced by the transition of oxygen atoms that are known as forbidden transitions in quantum mechanics. This name refers to a specific, slow, and low probability change in the energy state of the oxygen atom, which means the atom must have a long, undisturbed time between collisions to emit the green light. At lower altitudes where the air is denser, atoms collide quickly and prevent this specific transition from occurring. But in the thin upper atmosphere, the long interval between collisions is easily achieved. This beautiful, quiet detail of quantum physics means that the green light is literally a product of the near vacuum of space, a slow, patient light that can only fully express itself where the air is most rarefied and still. The aurora can actually be detected by specialized instruments in the infrared spectrum, showing us that the light show is much wider than what the human eye can perceive. While we are drawn to the luminous green and red, the energized atmospheric molecules also emit significant amounts of energy in wavelengths that are invisible to us, creating a silent, powerful heat signature that radiates out into space. This invisible thermal component is a key part of the total energy balance in the upper atmosphere, a hidden aurora of heat that shows the energy dissipation process extends far beyond the realm of human sight, connecting the solar input to the deep, complex dynamics of our upper atmosphere. The speed at which the auroral curtains can move across the sky is truly breathtaking, with shifts sometimes reaching thousands of miles per hour or several thousand kilometers per hour, though the appearance is often that of a graceful, slow ripple. It is not the air itself that is moving, but the invisible magnetic field lines and the boundaries of the energized particle flux that are shifting in response to the magnetosphere's constant interaction with the solar wind. This rapid displacement of the light boundary creates the illusion of a massive, shimmering fabric being tossed and turned by a cosmic hand, a quiet reminder that the atmosphere we inhabit is a dynamic, fluid system perpetually responding to forces that are both immense and completely unseen. The intense, localized arcs within the aurora are often referred to as rays, and these vertical striations are a visual representation of the magnetic field lines. The charged particles are tightly confined to the magnetic field, causing them to descend in narrow parallel columns that trace the magnetic geometry perfectly. When seen from below, these parallel columns of light create the illusion of rays or folds in a massive curtain, all converging toward a point high above the observer's head, which is the projection of the magnetic field line convergence. This beautiful, structured effect is a visible map of the Earth's invisible magnetic scaffolding, allowing us to see the planet's fundamental protective architecture traced out in pure, mesmerizing light. The total energy deposited into the Earth's atmosphere by a single, powerful geomagnetic storm is immense, far beyond anything a single human power plant could ever produce. A staggering flow of power for a natural event. Much of this energy quietly enters the polar atmosphere and is ultimately dissipated as heat and light, transforming the invisible medium of near-Earth space into a vast conduit for stellar energy. The lights are thus a beautiful, but also very powerful, side effect of the planet's continuous process of energy dissipation. A silent, cosmic power surge displayed for the attentive and patient observer. The green hue of the aurora is so dominant because the human eye is most sensitive to that specific wavelength of light, creating a perceptual bias. While the red and blue emissions are present, the eye's peak sensitivity aligns almost perfectly with the 557.7 nanometer wavelength of green light emitted by oxygen, making it the color we perceive as the brightest and most widespread, even if the total energy output across all colors is more evenly distributed. This biological preference means that a weak green display can often appear more vivid than a much stronger, yet red-hued display, asking us to recognize that the cosmic show is filtered not just by the atmosphere, but also by the quiet, internal machinery of our own vision. The subtle sensitivity of our own eyes thus plays a crucial, gentle role in translating the physics of the sky into the aesthetic experience we cherish. The concept of black aurora refers to the mysterious dark patches and holes that sometimes appear within the luminous curtain of the light show. These are not gaps in the atmosphere, but rather regions where the charged particles are suddenly diverted or inhibited from descending into the ionosphere, creating an absence of light against the glowing background. These dark voids often move and shift with the same speed and grace as the bright arc surrounding them, suggesting they are a negative image of the magnetic field's turbulence, a silent, empty space within the flow of solar breath. The black aurora reminds us that the process of the lights involves not just the presence of energy, but also the dynamic, instantaneous redirection of that energy by the invisible, shifting boundaries of the Earth's powerful magnetic shield. The maximum intensity of the northern lights often occurs near midnight local time, primarily because the Earth's rotation brings the observer directly under the region of the auroral oval that is closest to the magnetotail, where the magnetic field lines are most disturbed. As the planet turns, the observer travels from the dust sector, where the lights are often more diffuse and gentle, toward the midnight sector, where the energy stored in the tail is released in the form of substorms and brighter, more active displays. This is the moment when the magnetic pressure is at its height, the precise astronomical hour when the cosmic forces are most deeply aligned with the observer's quiet, solitary position on the ground. This simple, slow rotation of our world beneath the cosmic current is what dictates the peak hour of this spectacular celestial performance. The blue and purple colors are emitted by molecular nitrogen when it is highly energized, which usually occurs lower in the atmosphere than the primary green light. These colors, often appearing as subtle, sharp fringes at the bottom of the auroral curtain, are produced where the density of the air is higher and the energetic solar particles are rapidly losing their velocity in a flurry of quick, close collisions. This proximity to the ground, only around 50 to 60 miles, or about 80 to 100 kilometers, gives the lower edge of the aurora its distinct, sharp definition and its beautiful deep violet tones, a quiet transition zone between the near vacuum of space and the familiar dense air we breathe. The distinct chemistry of nitrogen at these specific altitudes offers a deeper dimension to the visible spectrum, a gentle signature of the atmospheric pressure at work. The northern lights can occasionally be seen from space by astronauts aboard the International Space Station, offering a unique, humbling perspective of the massive, glowing structure from above. From this quiet, orbital vantage point, the aurora appears not as an arc of light above, but as a vast, continuous, rippling sheet of emerald green and gold that covers the entire polar region, a massive crown of light encircling the planet. Observing the phenomenon from 250 miles, or about 400 kilometers, up allows for a comprehension of the true scale of the auroral oval, which spans thousands of miles, turning the mesmerizing display into a massive, shimmering blanket gently draped over the Earth's magnetic poles. This perspective transforms the phenomenon from a localized spectacle into a global, continuous, and breathing part of the planet's atmospheric skin. The mechanism that accelerates the solar particles to the speeds necessary to create the aurora is still a complex area of study, but it involves the electric and magnetic fields in the magnetotail. As the magnetic field lines snap and reconnect during a substorm, they create immense electric fields that violently fling the charged electrons and protons down toward the Earth's poles with incredible force. This final acceleration, known as field-aligned currents, is the ultimate driver of the light's intensity, a final burst of magnetic energy that ensures the particles have enough velocity to penetrate deep into the atmosphere and cause the gas atoms to glow with profound intensity. This immense, silent acceleration is the engine of the aurora's power, a final, invisible push that transforms potential energy into visible, rippling light. The intensity of the aurora is measured on a scale known as the planetary K-index, or Kp index, which quantifies the disturbance in the Earth's magnetic field due to the solar wind. This scale ranges from 0, representing very little activity, up to 9, indicating a major geomagnetic storm, which corresponds directly to the brightness and geographic extent of the auroral display. A gentle display may only register a Kp of 2 or 3, while a powerful, mesmerizing show that is visible far from the poles often reaches a Kp of 5 or higher, transforming the light from a quiet glow into a truly dynamic, sweeping curtain of color. This measured, quantitative index provides a silent language for anticipating the sky's performance, turning the subjective experience of light into an objective, predictable phenomenon, guided by the invisible fluctuations of the Earth's magnetic shell. The auroral display is often most colorful and intense during the equinoxes, specifically around the months of March and September. This subtle seasonal influence is known as the Russell-McFerran effect, which suggests that the alignment of the Earth's magnetic axis with the interplanetary magnetic field from the Sun, is slightly more favorable during these times. During the equinoxes, the magnetic field lines often connect more efficiently, allowing a greater influx of charged particles to enter the atmosphere even when the solar wind itself is not particularly strong. This gentle biannual alignment acts as a quiet catalyst, amplifying the spectacle of the lights and offering a consistent period of increased beauty for those who patiently observe the ancient calendar of the sky. The oldest written record describing the northern lights is believed to come from Babylonian clay tablets dating back to around 650 BC, illustrating humanity's ancient, enduring fascination with the phenomenon. These silent, cuneiform records show that even in the warm, southern latitudes of the Middle East, a very strong, powerful aurora was occasionally visible, pushing the auroral oval far beyond its typical polar boundaries. This documentation proves that the most powerful geomagnetic storms, capable of painting the sky with light for those far removed from the cold northern latitudes, have been a profound, occasional feature of the human experience for millennia. The ancient writings are a quiet testament to the enduring majesty of the lights and their rare, dramatic ability to touch even the most distant corners of the civilized world. The magnetic poles of the Earth are constantly moving and drifting, a slow, gentle shift that causes the center of the auroral oval to migrate over geological timescales. This quiet, ceaseless movement is caused by the slow, chaotic flow of the molten iron in the planet's outer core, which generates the magnetic field itself. The magnetic North Pole, for instance, has been moving rapidly towards Siberia in recent decades, causing a subtle, corresponding geographic shift in the regions that experience the most frequent and spectacular auroral displays. This slow, predictable, yet profound magnetic drift reminds us that the stage for the auroral performance is not static, but a living, slowly transforming surface, perpetually reformed by the powerful, deep dynamics of the planet's interior. The phenomenon of the pulsating aurora refers to patches of light that appear to rhythmically brighten and fade with a period of only a few seconds, creating a mesmerizing, hypnotic strobe effect in the night sky. This rapid, gentle fluctuation is believed to be caused by a corresponding, subtle oscillation in the magnetic field lines high above the Earth, which momentarily prevents the flow of particles before allowing them to cascade down again in a quick, silent burst. The pulsating lights often appear late in the auroral display, a gentle, fading cadence that marks the quiet transition of the substorm into its final, less energetic phase. These soft, rhythmic pulses offer a beautiful visual translation of the magnetic field's quiet, high-frequency breath in the upper atmosphere. The height of the aurora has a direct impact on the colors produced, acting as a natural, silent color filter based on atmospheric density. The lowest visible region, around 60 miles, or about 100 kilometers, is where the high density of nitrogen can sometimes produce the sharp, deep blue tones, while the vast middle region is dominated by the energetic green of lower-level oxygen atoms. Higher still, in the rarefied atmosphere above 150 miles, or about 240 kilometers, the patient red glow of oxygen is allowed to slowly emerge, showing us that the auroral curtain is not a uniform sheet, but a three-dimensional tapestry of color defined by altitude and the quiet, persistent pressure of the thin air. This vertical stratification is a profound visual lesson in the layered, chemical composition of our planetary envelope. The particles that cause the aurora can travel along the magnetic field lines from the north to the south pole and back again, a long, quiet journey known as magnetic mirroring. These charged electrons and protons are effectively trapped on the magnetic field lines, bouncing back and forth between the two polar regions in a rapid, continuous loop until they eventually lose enough energy to impact the atmosphere. This elegant, silent movement creates the perfect, simultaneous symmetry of the Aurora Borealis and the Aurora Australis, showing us that the light in the northern sky is connected by an invisible, high-speed orbital conversation with the light in the southern sky, all held together by the Earth's continuous, encompassing magnetic shell. The aurora is technically a form of plasma, which is a highly energized state of matter where atoms are stripped of their electrons, making it an ionized gas. When the charged solar particles collide with the atmospheric atoms, the gas briefly transitions into this plasma state before relaxing and emitting light, showing us a small, temporary pocket of highly energized matter right at the boundary of Earth and space. This luminous state is the most common form of matter in the universe, making the aurora a beautiful, nearby example of the same fundamental physics that governs the hearts of stars and the vast expanse of the galactic void. The curtain of light is thus a local, gentle manifestation of the universe's pervasive, energetic, and ionized nature. The brightest auroras are often preceded by the quiet appearance of a faint, steady arc of light on the northern horizon, a gentle herald of the more dramatic show to come. This initial arc is the visible, distant edge of the auroral oval, appearing as a soft, white or very pale green band that seems to sit motionless above the dark line of the Earth. As the geomagnetic activity increases, this quiet arc begins to rise and grow in intensity, developing the shimmering folds and rays that define the more active display. Observing this initial steady arc is a lesson in patience, teaching the observer to recognize the subtle, silent preliminary signs that the cosmos is preparing its grand, sweeping, luminous performance for the patient watchers below. The magnetic forces at play in the aurora are so strong that they can induce significant atmospheric drag on satellites in low Earth orbit. The heating of the upper atmosphere during a strong geomagnetic storm causes the air to expand and become slightly denser at orbital heights, increasing the resistance that satellites encounter as they silently glide through the tenuous air. This subtle, powerful drag requires satellite operators to occasionally raise the altitude of their spacecraft to counteract the energy deposited by the aurora, showing us that the beautiful light show has a tangible, physical consequence far above our heads, a quiet, measurable friction against the delicate mechanisms of human technology. The presence of a faint, almost white aurora is usually attributed to emissions from multiple gases, or when the light is so intense that the different colors blend together, overwhelming the eye's ability to distinguish them separately. In these very bright, gentle displays, the mixture of green, red, and blue wavelengths creates a spectrum that appears as a soft, milky white glow to the naked eye, particularly when the light is high overhead and the observer is looking up through the full depth of the atmosphere. This ethereal, pale luminance is often perceived as the most majestic and dreamlike form of the aurora, an undifferentiated sheet of pure light that seems to defy the very concept of color, a quiet, gentle curtain woven from the fusion of all cosmic energies. The study of the aurora, known as auroral physics, relies heavily on ground-based observation networks, which use sophisticated cameras and magnetometers to record the subtle movements and energy of the lights across vast regions. These silent, automated stations, often situated in remote, icy locations far from human settlement, work continuously to map the precise location and intensity of the auroral oval in real time. The data collected by these quiet instruments provides the essential, foundational understanding of the magnetic processes that drive the lights, allowing scientists to see the phenomenon as a continuous, predictable magnetic engine, rather than a mere fleeting visual spectacle. The steady, patient work of these instruments is a testament to the methodical observation of the cosmos. The subtle phenomenon of sunlight aurora occurs on the sunlit side of the Earth, where the emissions are much fainter and almost always invisible to the human eye due to the intense background light. While we usually only see the lights during the night, the process of particle collision and light emission is happening continuously on both sides of the planet. A silent, perpetual interaction with the solar wind, this daylight aurora, which requires specialized instruments to be detected, reminds us that the Earth is constantly enveloped in the magnetic conversation with the Sun, and that the light show is not just a nighttime performance, but a continuous global embrace of charged particles, a silent, powerful 24-hour process. The height of the red auroral emissions from oxygen atoms can be so great, sometimes exceeding 400 miles, or about 650 kilometers, that they are actually considered to be in the exosphere, the outermost layer of the Earth's atmosphere. At these immense distances, the density of gas is so low that the collisions between atoms are almost non-existent, allowing the energized oxygen atoms to take a very long, quiet time, sometimes up to several minutes, to release their energy as a photon of deep red light. This slow, patient emission, occurring at the boundary of space itself, gives the red aurora its deep, diffuse, and incredibly lofty appearance, a gentle crimson halo that seems to hang suspended at the absolute threshold of our planet's atmospheric reach. The concept of poleward moving auroral forms, or PMAFs, refers to small, bright, and localized auroral patches that rapidly drift toward the magnetic pole. These swift, silent movements are a visual signature of the direct reconnection of the magnetic field lines on the day side of the Earth, where the solar wind first impacts the magnetosphere. The PMAFs are essentially a rapid, luminous manifestation of energy being quickly injected from the front of the magnetosphere into the polar cap, a process that is invisible to the eye until it manifests as these sudden, fleeting streaks of light. Observing these quick, poleward dashes provides a beautiful, dynamic glimpse into the high-speed physics of magnetic reconnection, transforming the vast, static-seeming magnetic field into a scene of subtle, quick, and purposeful movement. The ancient Chinese referred to the northern lights as the burning dragon, or the fire of the heavens, weaving the spectacle into their vast, detailed astronomical and mythological frameworks. These descriptions, which speak of a great, serpentine beast dancing in the high northern sky, reflect the movement and vividness of the auroral curtains, which can twist and coil with immense, fluid grace. The cultural interpretation of the aurora as a powerful, living entity underscores the profound, universal human tendency to mythologize the most majestic celestial events, giving a massive, silent spectacle a tangible, powerful character drawn from the deep well of cultural imagination. These evocative names remind us that the aurora has always been a bridge between the quiet reality of the night sky and the rich, imaginative world of human spirit. Auroras on other planets in our solar system, such as Jupiter and Saturn, are vastly more powerful and intense than Earth's. Driven by magnetic fields that are orders of magnitude stronger, Jupiter's aurora, for instance, is continuously glowing and intensely bright in the ultraviolet and X-ray spectrums, driven by the planet's rapid rotation and the continuous stream of charged particles ejected by its volcanic moon Io. These massive, perpetually burning polar lights are a humbling testament to the sheer scale of the magnetic engine within the giant planets, creating a continuous global light show that makes our own terrestrial display seem like a delicate whisper in comparison. The existence of these planetary auroras demonstrates that the beautiful light show is a fundamental magnetic fingerprint common to all worlds that possess both an atmosphere and a powerful protective magnetic shield. The blue light from nitrogen atoms in the aurora is not always seen because it is easily absorbed by the lower, denser layers of the atmosphere before it can reach the observer on the ground. This phenomenon of light scattering and absorption means that even when the blue light is being actively emitted, its subtle presence is often quenched by the very air we breathe, leaving the dominant green to penetrate the thickest part of the atmosphere. The visibility of the blue and violet tones, therefore, is a quiet negotiation between the light's emission height and the clarity and density of the atmosphere below, making their rare, subtle appearance a gentle reward for the quiet observer under the clearest, coldest, and most transparent skies. The measurement of the auroral spectrum in the 19th century provided some of the first true scientific evidence for the composition of the upper atmosphere. Early spectroscopists, quietly examining the light from the auroral arc, discovered specific spectral lines that did not match any known element on Earth, leading to the temporary hypothesis of a new element called geocoronium. This mystery was eventually solved, revealing that the light was actually the signature of highly energetic oxygen atoms in a forbidden transition state, a profound discovery that quietly unlocked the secrets of the rarefied gases that exist far above the reach of conventional sampling. The aurora thus became a luminous, silent laboratory, allowing scientists to analyze the atmospheric chemistry of the planet's very highest, most distant envelope. The auroral display has a measurable impact on the ionosphere, the layer of the atmosphere rich with ionized particles, by dramatically increasing its temperature and density. The massive influx of energy from the solar wind during a storm heats the ionospheric gas, causing it to expand upward, a quiet, gentle swelling of the upper atmospheric layers. This thermal expansion is a key part of the energy dissipation process, transforming the kinetic energy of the incoming particles into silent, measurable heat that subtly alters the structure of the atmosphere itself. The aurora is therefore not just a visual spectacle, but an active, energetic agent that continuously models and influences the quiet physics of the near-space environment. A unique type of aurora, often called Steve, strong thermal emission velocity enhancement, appears as a narrow, majestic purple or magenta arc that runs east to west. Distinct from the typical green auroral oval, Steve is not created by the usual precipitation of charged particles, but rather by an incredibly fast, hot flow of plasma deep in the subauroral zone, creating a powerful, silent atmospheric friction that generates a deep, unusual color. This beautiful, relatively recent discovery shows us that the dynamic interactions between the atmosphere and the magnetosphere are more complex and varied than previously understood, offering a mysterious, narrow ribbon of unique light that quietly defies the conventional expectations of the polar light show. The appearance of a coronal aurora occurs when the observer is situated directly under the magnetic zenith. the point in the sky where the magnetic field lines converge vertically overhead. In this quiet, specific location, the auroral rays appear to stream down and fan out in a full, three-dimensional crown, creating the illusion of a massive, shimmering vortex or a central spire of light. This profound, singular perspective transforms the flat, distant curtain into a towering, encompassing spectacle that fills the entire sky, an unparalleled moment of magnetic alignment where the observer is standing directly in the silent, swirling heart of the auroral engine. The early 20th century Norwegian scientist Christian Birkeland proposed a theory that the aurora was caused by electrons from the sun, channeled by the Earth's magnetic field, a profound insight that was initially met with great skepticism to prove his theory. Birkeland constructed a terrestrial magnetic model called the terrella, a magnetized sphere placed inside a vacuum chamber, which beautifully reproduced the luminous glow and the channeling of light toward the poles. His quiet, persistent experimentation and the majestic simplicity of the terrella model laid the foundational groundwork for modern auroral physics, demonstrating that even the most sublime celestial events can be patiently and gracefully replicated within the confines of a quiet laboratory. The color of the aurora shifts subtly during the course of a single night, often beginning with a gentle, pale white or green arc near dusk, and evolving into the dynamic, powerful green and sometimes red curtains near magnetic midnight. This gentle, chromatic evolution is due to the changing energy and density of the particle precipitation as the Earth rotates beneath the auroral oval, with the most energetic and colorful events corresponding to the magnetic pressure peak around the midnight hour. The light display thus tells a silent, chronological story of the Earth's magnetic journey, offering a subtle, predictable rhythm that transforms the night sky into a vast, celestial timepiece. The lowest fringes of the auroral curtain are often so sharp and defined that they create the illusion of a palpable, tangible edge, a quiet testament to the rapid energy loss of the solar particles. As the electrons descend into the atmosphere, they collide with increasing frequency with the denser air, causing them to rapidly shed their energy until they can no longer excite the atoms to emit light, creating a relatively abrupt lower boundary. This sharp, luminous limit is usually found around 60 miles, or about 100 kilometers above the surface, marking the precise altitude where the thin air finally absorbs the last powerful breath of the solar wind, creating a perfectly defined silent line where the light ends and the familiar atmosphere begins. The auroral curtains can stretch for thousands of miles across the polar sky, often forming a continuous vast band that encircles the pole, giving the phenomenon an incredible, encompassing scale. While an observer on the ground sees only a small, localized segment of this light, the full structure is a continuous magnetic stream, spanning widths that can measure over 1,000 miles, or about 1,600 kilometers from east to west. This immense, silent scale, often stretching across entire continents, transforms the aurora from a local event into a global, planetary embrace, a continuous, shimmering ribbon of light woven into the magnetic fabric of the far northern latitudes. The phenomenon known as proton auroras is invisible to the human eye, appearing as a soft, diffuse glow in the hydrogen alpha spectrum. But it is scientifically significant as it is driven by incoming protons rather than electrons. These particles, which are the nuclei of hydrogen atoms, create their light by capturing an electron from an atmospheric atom, causing the resulting hydrogen atom to emit a faint light before reionizing. This quiet, invisible light show often manifests as a broad, gentle patch of luminescence that is much more diffuse and less structured than the electron-driven curtain, showing us a subtle secondary layer of the solar wind's continuous, unseen interaction with our atmospheric shield. The aurora can actually be observed in the far reaches of the Antarctic, where the Aurora Australis occasionally illuminates the frozen landscape with its spectacular, symmetrical display, though less often seen by humans due to the remote nature of the continent. The southern lights are a mirror image of the northern lights, often creating stunning visual spectacles over the quiet, vast ice sheets. These deep southern displays are a silent, profound affirmation of the Earth's global magnetic symmetry, proving that the solar wind's energy is distributed and expressed in a perfectly balanced manner across the planet's two magnetic poles. The appearance of a pale pinkish-red color at the very bottom edge of the auroral curtain is sometimes caused by the gentle excitation of molecular nitrogen at extremely low altitudes, close to 50 miles, or about 80 kilometers. This subtle, beautiful hue, often only a few feet thick in the vast curtain, represents the absolute final dissipation of the solar particles' energy as they encounter the densest atmospheric layer where light emission is still possible. The fleeting soft pink band is a quiet signature of the most vigorous, deepest penetration of the solar wind, a beautiful, delicate line drawn at the very lowest visible boundary of the entire celestial light show. The velocity of the particles that create the aurora is not constant, and they are typically slowed by a massive, invisible magnetic barrier known as the bow shock before they can be funneled into the polar regions. This bow shock, where the supersonic solar wind first encounters the Earth's magnetic field, acts as a gentle, immense brake, slowing the charged particles from over 1 million miles per hour down to a manageable subsonic speed, or from about 1.6 million kilometers per hour down to a slower, more manageable flow. This immense, silent deceleration is a crucial first step in the auroral process, a necessary magnetic negotiation that allows the solar wind's powerful energy to be gracefully managed and channeled toward the poles. The study of the aurora played a critical role in the development of the field of plasma physics, as scientists sought to understand the behavior of the highly ionized gas in the near-Earth space environment. The visible lights provided a clear, luminous signature of plasma interaction, allowing researchers to develop complex theories and mathematical models to describe the motion of charged particles in immense magnetic fields. The spectacular flowing colors of the aurora were thus the first, most beautiful experimental evidence of these fundamental plasma dynamics, turning a celestial wonder into a profound, generative catalyst for an entirely new branch of modern physics. The auroral light is often highly polarized, meaning the light waves vibrate primarily in a single plane, a subtle optical characteristic that is usually invisible to the naked eye. This polarization is a direct result of the electrons being channeled along the magnetic field lines, causing the emitted light to adopt a specific directional signature. While this detail is not visually apparent, it is a crucial scientific signature, allowing specialized instruments to quietly decode the precise direction and magnetic geometry of the solar wind's influence on the Earth's upper atmosphere. The Earth's magnetic field acts as a perfect barrier for the vast majority of the solar wind particles, gracefully deflecting them around the planet in a vast, invisible stream. Only a small, select fraction of the particles are funneled into the polar regions to create the light show, a quiet, effective leakage through the magnetic defenses at the cusp regions near the poles. The aurora is therefore the beautiful, visible manifestation of this single, small point of magnetic vulnerability, a controlled, channeled release of energy that protects the rest of the planet from the full, continuous power of the distant, fiery sun. The concept of diffuse aurora refers to a soft, uniform, and relatively unstructured glow that can cover wide swathes of the polar sky, often appearing before or after the more structured, active curtains. This gentle, wide luminescence is thought to be caused by a gradual, slow scattering of charged particles into the atmosphere from a stable, non-turbulent region of the magnetosphere. The diffuse aurora, which lacks the sharp edges and dynamic movement of the arcs and rays, is a sign of a more settled, quiet, magnetic environment, a beautiful, constant background illumination against which the more dramatic, tempestuous curtains later take their brief, intense form. The appearance of spiral or helix formations within the aurora is a rare and majestic event, caused by the charged particles being tightly confined and spiraling around the Earth's magnetic field lines as they descend. This helical motion, a fundamental characteristic of charged particles in a magnetic field, creates the visual effect of the light twisting into massive silent coils and spirals that can slowly rotate in the night sky. The beautiful geometric shape is a direct, visible consequence of the Lorentz force acting on the electrons, transforming a principle of electromagnetism into a stunning three-dimensional display of quiet, cosmic engineering high above the planet. The green auroral light, despite its prevalence, is highly monochromatic, meaning it consists almost entirely of a single, precise wavelength of 557.7 nanometers. This extreme spectral purity is the signature of the forbidden transition of the oxygen atom, which releases its energy at this specific, solitary frequency, giving the green color its luminous, almost otherworldly quality. This singular, focused wavelength is why the green hue appears so distinct and often seems to shimmer with a unique, ethereal intensity, a quiet testament to the meticulous, unchanging quantum mechanics at play in the atmosphere's upper, coldest reaches. The lowest region of the auroral phenomenon often experiences a dramatic increase in the density of free electrons, which strongly affects radio communications, creating what is known as auroral absorption. The massive influx of charged particles in the ionosphere causes radio waves, particularly those in the high-frequency band, to be absorbed or scattered as they pass through this energized region, leading to quiet, temporary blackouts in long-distance communication links. This powerful, silent interference is a tangible reminder that the beautiful lights in the sky are a truly energetic, electrodynamic event, capable of subtly disrupting the complex, delicate pathways of human technology across vast northern distances. The height of the auroral curtain dictates its perceived distance and geometry to the observer, making an aurora that is directly overhead appear much closer and more structured than one seen near the horizon. An arc seen near the horizon is often perceived as a distant, gentle band of light, while the same arc passing directly overhead transforms into a majestic, towering crown or a swirling vortex, with its rays pointing straight down toward the observer. This profound shift in perspective is purely a geometrical effect, showing us how the slow, slight movement of the planet beneath the static auroral oval can completely transform the experience of scale and proximity for the quiet observer on the ground. the energy stored in the Earth's magnetotail, the magnetic field stretched out on the night side of the planet, can be likened to a massive, quiet rubber band being slowly stretched and held taut by the continuous pressure of the solar wind during a geomagnetic substorm. This immense, stored potential energy is suddenly released when the magnetic field lines quietly snap back to a more stable configuration, flinging charged particles down into the atmosphere to create the intense, dynamic phase of the aurora. This magnetic stretching and sudden release is the core mechanical engine of the most spectacular displays, a silent, powerful process of energy storage and sudden, luminous conversion. The ancient Inuit people of Greenland and North America had rich, quiet traditions about the aurora, often viewing the lights as the spirits of the dead, playing a form of celestial football with the skull of a walrus, or sometimes as a source of warning or guidance. These stories personify the flickering, quick movements of the lights, linking the vast, cosmic spectacle to the familiar elements of their Arctic world and their deep ancestral beliefs. Such profound cultural narratives transform the cold, scientific event into a living, responsive entity, demonstrating the human need to peacefully integrate the magnificent, inexplicable displays of nature into the quiet fabric of spiritual understanding. The intense, rapid movements of the auroral curtains, sometimes referred to as dancing, are primarily driven by the electric fields that form across the auroral oval, pulling the charged plasma sideways. These electric fields, generated by the interaction of the solar wind and the magnetosphere, act as massive, silent conveyors, quickly shuffling the luminous plasma across the sky and creating the visual illusion of a powerful, rhythmic, and intricate dance. This beautiful, observed movement is thus a direct visible consequence of the powerful, unseen electromagnetic forces that continuously shape the quiet flow of energy in the near-Earth space environment. The red color of the highest altitude oxygen is often referred to as the long-lived emission because the atoms must wait patiently for an extended period, sometimes up to several minutes, to release their energy as a photon. This long, slow life of the energized state, only possible in the near vacuum where collisions are incredibly rare, is what gives the red light its high, diffuse, and gentle appearance, often forming a soft, majestic arc high above the brighter green curtain. The presence of this crimson glow is a quiet, profound indicator of the extremely low density of the air at that height, a beautiful signature of patience in the outermost fringes of the atmosphere. The study of the aurora allows scientists to remotely measure the energy and composition of the solar wind, using the Earth's atmosphere as a massive, silent spectrometer. By patiently analyzing the specific colors and intensities of the light, researchers can quietly infer the velocity, density, and chemical composition of the incoming charged particles, offering a valuable, continuous diagnostic of the distant solar engine. The spectacular, colorful display is thus a beautiful, luminous tracer, transforming the cold vacuum of space into a powerful, quiet measurement tool that continuously monitors the heart of our solar system. The quiet phenomenon of the auroral breakup refers to the sudden, explosive transition from a stable, gentle arc of light to a dynamic, rapidly moving, and highly structured curtain that expands across the sky. This powerful, luminous event is the visual marker of a geomagnetic substorm onset, the precise moment when the magnetic energy stored in the magnetotail is violently released, transforming the quiet night into a scene of immense, swirling activity. This dramatic, sudden awakening of the lights is the most sought-after spectacle for aurora watchers, a silent, powerful signal that the cosmic forces have reached a peak of intense, energetic, and majestic release. The intense energy influx during an aurora can temporarily change the electrical charge distribution in the upper atmosphere, causing quiet, subtle alterations to the Earth's global electric circuit. This vast planetary circuit connects the high-altitude electric fields to the ground, and the immense, focused energy of the aurora introduces a temporary but powerful current into this global flow. The beautiful, visible light is thus a localized, luminous manifestation of a much larger, global electrical process, showing us that the planet is continuously enveloped in a subtle, powerful, and circulating electromagnetic field that is quietly influenced by the continuous solar breath. The color yellow in the aurora is extremely rare and is theoretically caused by a combination of the green light from lower altitude oxygen and the subtle red light from high altitude oxygen blending together. This quiet, fleeting hue would require a specific, perfect balance of atmospheric density and particle energy to manifest, creating a gentle, golden glow that is rarely distinct enough to be perceived by the human eye. The potential for this soft, golden yellow color reminds us that the auroral spectrum is a continuous blend of emissions, and the more commonly seen colors are merely the dominant, brightest signatures in a much richer, quieter, and continuous chromatic tapestry. The presence of the aurora has a subtle, measurable impact on the orbital paths of certain satellites in near-Earth orbit, which are sometimes used to measure the properties of the charged particle flows. These spacecraft quietly track slight deviations in their flight paths and local conditions, caused by interactions with the electromagnetic fields and energized plasma that help create the light show. This gentle, precise monitoring offers a quiet, scientific means of understanding the immense, invisible fields that shape the space environment around our planet, using the orbiting machinery as a sensitive probe into the deep magnetic forces of the cosmos. The most dramatic, visible auroras are often a delayed response to a major solar flare, arriving at Earth 1 to 3 days after the initial violent outburst on the Sun's surface. The flare itself releases intense X-rays and ultraviolet radiation that travel at the speed of light. But the coronal mass ejection, which contains the slow, massive cloud of charged particles that creates the spectacular light, takes time to cross the 93 million miles, or about 150 million kilometers, of interplanetary space. This quiet, inherent time lag allows scientists to predict the potential for a major display, transforming the Sun's distant eruption into a highly anticipated, scheduled performance for those who patiently wait beneath the dark polar skies. The height and thickness of the auroral curtain are often inversely related. A very tall, diffuse curtain is indicative of a weak, low-energy display, while a short, sharp curtain is a sign of intense, highly energetic particle precipitation. In a weak event, the particles dissipate their energy slowly over a vast, tall distance, creating a faint, stretched curtain, while in a powerful event, the highly energized particles penetrate deep and stop abruptly, creating a compressed, sharp, and brilliant line of light. This quiet, visual scaling principle allows the observer to subtly gauge the raw magnetic energy of the display simply by examining the majestic, geometric structure of the luminous curtain. The concept of a mantle aurora refers to the faint, continuous glow that surrounds the auroral oval, a soft, wide luminescence caused by the slow, continuous leakage of charged particles from the magnetospheric mantle. This extremely subtle light is a quiet signature of the steady, normal flow of the solar wind, appearing as a gentle, almost undetectable background illumination that perpetually bathes the highest polar regions, the mantle. Aurora is a testament to the continuous, low-level interaction between the Earth and the Sun, a silent, constant glow that is only overwhelmed and brightened when a powerful, energetic substorm transforms the quiet background into a dazzling, dynamic spectacle. The visual perception of the aurora is greatly enhanced by the prolonged darkness of the polar winter, where the sun remains below the horizon for weeks or months, creating a continuous, perfect canvas for the light show. This period of deep, uninterrupted night allows the human eye to fully adapt to the low light conditions, maximizing the sensitivity to the faint auroral emissions and enhancing the perception of the subtle colors and rapid, quiet movements. The extreme cold and the pervasive, uninterrupted darkness of the high latitudes are thus a crucial, silent prerequisite for the full, majestic appreciation of the northern lights' most delicate and fleeting visual details. The light of the aurora is so quiet and diffuse that it does not cast sharp shadows, instead creating a soft, ambient glow that gently illuminates the vast, snowy landscape below. Even the most intense displays, while visually overwhelming, distribute their light so evenly and widely across the upper atmosphere that the illumination is more like a gentle, green, moonless twilight than a focused light source. This soft, shadowless luminescence adds to the ethereal, dreamlike quality of the aurora, transforming the ground beneath into a quiet, peacefully lit stage for the continuous silent ballet of the solar wind and the Earth's magnetic heart. The existence of recurrent auroras refers to the tendency for the lights to reappear on successive nights after a major solar event, following the 27-day rotation period of the Sun. If an active region on the Sun that produced a strong solar wind stream is oriented toward Earth, it will likely swing back around and face the Earth again, approximately 27 days later, leading to a predictable, quiet resurgence of the auroral activity. This rhythmic, almost monthly return of the celestial display is a profound, silent clock, connecting the slow, majestic rotation of our distant star to the recurring beauty and predictability of the lights in our own polar sky. The study of the aurora provides crucial data for understanding space weather, which is the concept that the sun's activity can impact conditions on Earth and in near-Earth space. The intensity and movement of the auroral oval are direct visual indicators of the severity of a current geomagnetic storm, allowing space weather forecasters to quietly monitor the potential risks to satellite systems, GPS navigation, and ground-based power grids. The lights are thus a magnificent, silent reporting system, translating the complex, powerful flows of the solar system into a visually stunning, real-time alert for our technological world. The rapid, high-frequency flickering sometimes observed in the aurora is caused by microbursts of electrons that are precipitated into the atmosphere in extremely brief, quick pulses. This visual shimmer is a direct signature of subtle, fast-moving instabilities in the magnetosphere, where the magnetic fields briefly allow tiny, rapid streams of particles to cascade down. The visual effect is a mesmerizing, almost hypnotic dance of light that seems to pulse with a hidden, high-speed energy, a quiet, rhythmic beat that is dictated by the precise, fleeting electromagnetic conditions high above the atmosphere. The auroral display can also be studied through the faint X-rays produced when the most energetic electrons plunge into the upper atmosphere, generating a delicate Bremsstrahlung glow that is detected by satellites and high-altitude instruments rather than by the naked eye. As these highly energetic electrons collide with atmospheric atoms, they emit subtle, downward-traveling X-rays, providing scientists with another way to trace where the energy is being deposited. This quiet, invisible radiation is a deeper signature of the solar wind's penetration, a high-energy whisper that complements the visible curtain of light far above the dark ground. The concept of diffuse patches in the aurora refers to soft, cloud-like areas of luminescence that often appear in isolation, far from the main auroral oval. These gentle, isolated glows are thought to be caused by a more sporadic, irregular scattering of energetic electrons into the atmosphere, creating pockets of soft light that appear and disappear with no discernible structure or connection to the larger magnetic forces. These quiet, ephemeral patches add a layer of soft, unpredictable beauty to the display, showing that the energy leakage from the magnetosphere is not always a grand, structured event, but sometimes manifests as a gentle, quiet, and isolated glow. The beautiful, rippling folds in the auroral curtains are purely an optical effect caused by the vast, luminous sheet being viewed edge-on, giving the illusion of depth and folding. The true shape is an immense, incredibly thin, vertical sheet of light that extends hundreds of miles into space, and the folds appear when the sheet itself is slightly tilted and perturbed by the magnetic field, allowing the observer to see through the thin dimension of the light. This majestic, three-dimensional illusion transforms a simple, flat structure into a deep, undulating spectacle, a visual trick of immense scale that enhances the ethereal, dreamlike quality of the light. The auroral activity exhibits a pronounced 24-hour cycle, often being weakest during the hours around noon and reaching its peak intensity near magnetic midnight, following the Earth's quiet, continuous rotation. This simple, daily rhythm is a consequence of the solar wind's constant, steady pressure, which causes the magnetosphere to be most compressed on the day side and most elongated and energized on the night side, where the stored energy is finally released. This predictable, hourly cadence allows for the patient anticipation of the light show, transforming the night sky into a reliable, quiet schedule, governed by the continuous flow of the solar system. The faint green air glow, which is a constant, subtle luminescence of the atmosphere, even without a strong auroral event, is caused by the slow, quiet recombination of oxygen and nitrogen atoms, while the aurora is a dynamic, powerful event driven by solar wind particles. The airglow is a continuous, gentle background emission, a sign that the atmospheric chemistry is always subtly energized by the sun's ultraviolet radiation. The aurora is thus a powerful, temporary intensification of this perpetual soft background glow, a dramatic magnetic event layered upon the quiet, continuous breathing of the planet's atmospheric envelope. The total number of charged particles that rain down on the Earth during a strong aurora is staggering, potentially exceeding 10 million particles per square meter every second. This massive, silent deluge of electrons and protons, which are the fundamental components of the solar wind, is what provides the immense energy necessary to transform the neutral atmospheric gases into a luminous spectacle. The aurora is therefore a majestic, visual translation of this quiet, continuous, and overwhelming cosmic bombardment. showing us the density and sheer volume of the solar energy that is gracefully channeled and dissipated by our planet's protective magnetic field. The concept of a rayed arc refers to the majestic luminous curtain where the light is composed of sharp, distinct vertical streaks or rays, indicating the high alignment of the magnetic field lines. This is the most sought after and beautiful form of the aurora, where the light appears to be pouring straight down from a specific, towering edge, transforming the diffuse glow into a structured, intensely vibrant sheet. The rays are a perfect, visible illustration of the charged particles traveling along incredibly narrow, parallel pathways, silently tracing the magnetic scaffolding of the Earth as they descend in a luminous collective column. The auroral display, particularly the green light, is often mistaken for cloud cover when seen on the horizon because of its diffuse, misty appearance. However, the aurora is always located far above the weather, and a crucial tell is that the stars can be quietly observed shining clearly through the auroral light, a feature impossible for an ordinary cloud. This silent optical test confirms the immense altitude of the phenomenon, showing that the shimmering green is a beautiful, ethereal luminescence that exists in the rarefied quiet of space, far beyond the reach of Earth's familiar weather systems. The rare appearance of a deep blue or violet corona high overhead is caused by the gentle excitation of molecular nitrogen ions, which requires highly energetic particles to penetrate to very low altitudes, below the primary green layer. This profound, rich coloring adds a majestic, subtle depth to the auroral spectrum, often appearing as a sharp, fleeting frame at the bottom edge of the massive curtain. The fleeting glimpse of these deep colors is a quiet signal of the solar wind's most vigorous, forceful entry, a powerful signature translated into a brief, magnificent band of violet light. The study of the aurora began to truly accelerate during the International Geophysical Year in 1957 to 1958, a global cooperative effort where numerous observation stations were established across the Arctic and Antarctic. This concerted, worldwide effort allowed scientists to combine synchronized data from magnetometers and cameras for the first time, transforming the study of the lights from isolated observations into a comprehensive global understanding of the magnetosphere's dynamics. This quiet, scientific collaboration marked a profound turning point, confirming the auroral oval as a continuous, planetary feature driven by solar forces. The Earth's magnetic field occasionally experiences a reversal, a slow, quiet flipping of the north and south magnetic poles over geological timescales, which would profoundly alter the geographic location of the auroral oval. During the period of transition, the magnetic field weakens dramatically, potentially allowing the aurora to be seen across the entire globe, even at the equator, as the planet's shield becomes momentarily porous and chaotic. While this is a slow, powerful geological process, the thought of an equator-spanning aurora is a quiet, stunning contemplation of the planet's vast, transforming magnetic history. The auroral activity can show subtle differences between the northern and southern hemispheres, a gentle imbalance caused by the slight offset of the Earth's magnetic poles from the geographic poles and the intricate configuration of the magnetic field. At times, the Aurora Borealis may appear marginally more frequent or intense for patient northern watchers than the Aurora Australis does for those in the remote south, while under other conditions the balance can shift. This minor, beautiful variation is a quiet, nuanced signature of the small complexities inherent in the planet's continuous, protective, magnetic architecture. The height of the auroral light emissions can be accurately calculated using simple trigonometry from two different observation points on the ground, a method called triangulation. By measuring the angle of the same specific point on an auroral arc from two separated locations, scientists can quietly and precisely determine the towering altitude of the light source, confirming the immense distance between the Earth and the dancing curtain. This quiet, classical measurement technique transforms the ephemeral, shifting light into a tangible, geometrically defined structure, confirming its presence far above the familiar atmosphere. The auroral light is constantly shining, even during the day, where it is only masked by the overwhelming brightness of the sun, requiring specialized ultraviolet cameras to be detected. The solar wind's constant interaction with the Earth's magnetic field is a continuous 24-hour process, meaning the light-emitting collisions are perpetually occurring over the polar regions. This silent, invisible daytime aurora reminds us that the magnetic conversation with the sun never ceases, transforming the sunlit polar sky into a continuous, unseen canvas of luminous activity. The appearance of the aurora can sometimes be accompanied by a phenomenon known as magnetic pulsations, which are quiet, rhythmic oscillations in the Earth's magnetic field that are invisible to the eye, but detectable by sensitive instruments. These subtle, pervasive waves are a signature of energy traveling through the magnetosphere, silently accompanying the visual light show as a low-frequency electromagnetic vibration. The magnetic pulsations offer a quiet, unseen soundtrack to the luminous dance, showing that the atmosphere is vibrating in response to the deep, resonant frequencies of the solar wind's immense pressure. The strongest recorded aurora in history, known as the Carrington event of 1859, was so intense that the lights were seen as far south as the Caribbean and Rome, demonstrating a profound, unprecedented expansion of the auroral oval. This majestic, globally visible spectacle was a tangible result of an immense solar storm, powerful enough to induce massive currents in telegraph wires and completely overwhelm the planet's magnetic shield. The quiet, historical record of this single, immense event serves as a powerful testament to the sheer potential magnitude of the sun's magnetic breath and its ability to briefly turn the entire sky into a luminous, overwhelming theater. And so, our journey through the ethereal world of the Northern Lights comes to a gentle close. We have wandered through the vast, quiet processes that link the fiery heart of our distant sun to the cold, magnetic stillness of our planet's polar skies, seeing the solar breath transformed into rippling curtains of light and the simple density of oxygen painted in luminous green and deep crimson. These facts, from the powerful silent speed of the solar wind to the patient, slow energy release of the red exosphere, serve not as mere information, but as gentle anchors, grounding the busy mind in the quiet, immense realities of the cosmos. The lights, with their predictable 11-year cycle and their nightly magnetic dance, offer a powerful invitation to embrace the rhythm of a scale far grander and more tranquil than our own daily concerns. Allow the thoughts of this vast, continuous process, the magnetic fields, the electron showers, and the patient color changes, to carry you softly into rest. Let the image of the towering silent curtain, stretching thousands of miles across the northern darkness, become a serene, beautiful image that settles your spirit and quiets your mind. The Earth continues its slow, predictable rotation beneath the spectacle, a gentle, comforting motion that promises a quiet repose and a restful, profound night. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of the Aurora Borealis and the gentle music carry you softly into rest. Sleep well. Good night.